Hello, I wanted to talk about a topic that a lot of students have trouble with, which is multiplying fractions. The first thing I wanted to talk about when referencing multiplication of fractions is using area models to demonstrate what's going on. First, I want to talk about why using an area model is helpful for multiplying fractions. So let's say I have a square. I'm going to make this a blue square because I like to use blue for positive values. And this square is going to have a side length of 1 on both sides. Now, what does that make the area of this square? Well, I'm just going to say that this square has an area of 1 because its two side lengths, because its side lengths are 1. And the reason for this, right, is because it's 1 square, right? Now, let's imagine that I take this square and I copy this a few times so that I have 4 going this way and I'm going to have 3 going down. Well, if I've got 1, 2, 3, and 1, 2, 3, 4, then I am performing a multiplication operation of 4 times 3. Now, there's a couple of different ways to think about this idea, right? I have a rectangle here that has 12 squares in it, because 4 times 3 is equal to 12. But I want to talk about multiplication as this idea of repeated addition. In this case, right, I want to add, if I'm going across, I have 4 in this row. And as I go down, I have 4 more in this row, and I have 4 more in this row. And so if I move downwards, I'm adding 4 3 different times, and that gives me 12. If I think about this in columns, I've got 3 in this column, 3 in this column, 3 in this column, and 3 in this column. And when we add going across, that also gives us 12. So this idea of multiplication is this idea of repeated addition, right? We find the area of this rectangle by filling it with squares of side length 1. And when we fill that rectangle with these squares, it's really the multiplication of its two side lengths, 3 and 4. And this is true of any pair of numbers, right? If I were to make the side length of this rectangle 5, then I would have 3 rows of 5, and I would have 5 columns of 3. And so we can think of this as repeated addition as well. And this concept of repeated addition can be very helpful in other ways. Now, the main thing I wanted to focus on was this area model here, because I want to start talking about fractions. So let's imagine that I have this square here. In the two sides of the square are going to be length 1. So the length of that this rectangle above is 1, right? Or its side lengths are 1 by 1. Now, why is this important? Well, that means that the area of this square is 1. Now, I want to think about these rectangles on the sides because they're going to be important here, because I want to represent this rectangle as having as representing the value of 2/5. Well, how do I represent 2/5? Well, if I take this square, or excuse me, this rectangle, and I divide it into a number of squares, then oops, then I will have 5 squares going across my rectangle. All right, give me a second to get that done. Okay, so I've got 5 squares now. Now this one over here, I want this one to represent 3/4. So instead of squares, this is going to end up being rectangles, right? But it'll be the same sort of idea. So now, if I were to fill in this area here as being 2 of my 2/5, and this as being 3 of my 3/4, then we can see that we have 3/4 of this rectangle and 2/5 of this rectangle. Now, with our area model, right, we multiplied the length of the top by the length of the bottom. So we're going to have a similar idea happening here with the length of my 2/5 being used to define the area here. And actually go all the way across like that. And we're going to go all the way across like this. And so the area is going to be this filled in area here. But how do I know how big of an area that is? Well, I can continue this drawing of lines for all of the dividing sections in here. So if I do that for this one as well, then this one, and this one, then we see that the rectangle, or the square that represents my area of 1, is now divided into 5 sections, just like this area here was divided into 5 sections. I'm also going to do that for the side over here, and split this into its 4 sections. And so now, how many sections is my square divided into? It's divided into 1, 2, 3, 4, 5 sections going across, and 1, 2, 3, 4 sections going down. So why is that helpful? Well, the reason for that is because that's the denominators here, 5 and 4. And so the area of each of these rectangles in here inside of my square of area 1 is going to be 4 times 5, right, which is 20. And then it's just going to be one of those sections for each of these rectangles in here. After that, what about the numerator? Because the numerator is not just one of these rectangles. It's actually 1, 2 going across, and 1, 2, 3 going down. So a total of 6. And so what happens here is that instead of the top being just one of those sections, it is 2 times 3. And so we see we have an area of 6. And if we multiply that, that's 6 going here, and so we have 6/20 is the area of the rectangle represented here in blue after multiplying 2/5 and 3/4. Now, if you're familiar with fractions, you will probably notice that this number here is reducible, right? If we were to divide 6 by 20, and let me grab a new layer here, right? If we take 6 and we divide it by 20, then we are going to get, well, if I do long division here, 6 divided by 20, 20 doesn't fit inside of 6, but it does fit inside of 60. So it's going into 6 0 times, but it goes into 60 3 times. And so that's 0.3. Well, we can find other numbers that are 0.3, such as 3/10. 3 divided by 10. 10 doesn't go into 3 any times at all, but if we add our decimal and go over one more, 10 does go into 30, 3 times. And so these two fractions represent the same amount. So how can we go from this top fraction to this bottom fraction? Well, I like to look at this as finding shared factors between the numerator and the denominator. And so if I take 6 and I break it down into its factors of 2 times 3, and I take 20 and I break it down into the factors of 2 times 10, then we can see that this is actually the same as 2 divided by 2 multiplied by 3 divided by 10, because we had the exact same thing happening back here, where I had 2/5 times 3/4. 2 times 3 divided by 4 times 5 is the same sort of behavior here. And so when I split them apart like this, well, what is 2 divided by 2? Well, 2 divided by 2 divided by 2 is 1, and 3/10 is, well, just 3/10. And we know that anything times 1 is just whatever that anything is, so we keep the 3/10 as our final answer. And so whenever you see shared factors between the numerator and the denominator, they can cancel out. Now, is there a way we could have noticed this sooner? Because we had 3/4 times 2/5. We can actually notice these shared factors here. This 2 can cancel out with one factor of the 2 in the denominator here, leaving a denominator of 2 here, and now it's 3/2 times 1/5. And when we do that 3/2 times 1/5, we get a result of 3 divided by 10, as we just multiply across the top and then multiply across the bottom. All right, I hope that this idea helps solidify what is going on when we multiply fractions. And have a good day.